periodic table of elements was created by the Russian chemist Dmitry Mendeleev and currently has 117 elements, 57 of which were added onto his table later as they were discovered. Mendeleev is known as the father of the periodic table because he was the first person to correct the atomic masses of many elements. He also found the correct valence electrons of many elements in order to correct their atomic weight. He also arranged some elements by their atomic weight but moved certain elements, such as placing tellurium before iodine, because that element's properties resembled those of other elements on opposite sides of the table. The current periodic table is arranged by atomic number, not atomic weight. The metals are on the left of the periodic table, separated by the non-metals by a dark stair-step line, while metalloids are the elements that border this line. Metals are good conductors of heat and electric current, and most are solid at room temperature. There is a large variation between nonmetals, but they generally are poor conductors of electricity and heat. Metalloids have properties that are similar to both metals and nonmetals. Elements are classified into groups, periods, and blocks. Groups or families are the vertical columns located on the periodic table. Groups contain elements with very similar properties and have special names such as Group 1A being alkali metals and 2A being alkaline earth metals. 7A are called halogens and AA are the noble gases. Periods are the horizontal rows of the table and they signify the number of shells or the clouds of electrons. Blocks correspond to the highest occupied sublevel and helps determine electron configurations. Atomic size and ionic size increases from the top to the bottom within a group and from left to right across a period, while ionization energy and electronegativity tends to decrease from top to bottom within a group and decreases from left to right across a period.
There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, nitrogen, and radium, and nickel, neodymium, neptunium, germanium, and iron, and americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, titanium, and indium, gallium, and iodine, thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, and radium, strontium, and silicon, and silver, and samarium, bismuth, and lithium, beryllium, and barium. Helium and helium and hafnium and erbium, phosphorus and francium and fluorine and cerium and manganese and mercury, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium, platinum, plutonium, palladium, promethium, palladium, and tantalum, cesium, and thallium, and tellurium, cadmium, calcium, and curium, and curium. There's silver, californium, and fermium, berkelium, and also mendelevium, and cynium, nobelium, and argon, kryptonium, and radon, zinc, and rhodium, and chlorine, carbon, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard, and there may be many others, but they haven't been discovered.